Hello class, my name is Yu-Ching Lin. Thanks for joining me today to learn about dependency injection. In this presentation, we will take a deep look at dependency injection, a design pattern that is becoming increasingly popular in software development. We will cover what dependency injection is, why it is important, and how it can be implemented in your code. Before we start, what do you think dependency injection means literally? Does this mean injecting something to somewhere? Well, we will figure it out through this presentation. First of all, let's start with what dependency injection is. Dependency injection is a design pattern used in software development to manage dependencies between different parts of a program. Essentially, it allows you to decouple classes or modules from their dependency by injecting them from the outside. This means that instead of the class or module creating its own dependency internally, it relies on an external source to provide them. Using dependency enables developers to write code that is more modular and easier to change, as well as promoting better separation of concerns. Now, I will provide an example with and without dependency injection to give you a deeper understanding. In this example, the engine class is responsible for providing power to the car to make it move, which can be turned on and off. The car class represents a car that contains an engine and can be started. Let's start with an example of not using dependency injection. Here is what the code might look like. In this example, the car class creates a new instance of the engine class inside its constructor. This means that every time we create a new car object, we will also create a new engine object. This tightly couples the car class to the engine class, making it difficult to change the implementation of the engine class or to test the car class in isolation. Now, look at an example of using dependency injection. The car class relies on an external engine instance provided via its constructor. This decouples the car class from the engine class, making it easier to change the implementation of the engine class or to test the car class in isolation. By using dependency injection, we can separate concerns and manage dependencies between different parts of our program, making our code more modular and flexible. By having the concept of dependency injection, we can easily think of the benefits it brings for developers. For example, it makes testing easier. We can easily swap out dependencies with mock objects or other test implementations, making it easier to write unit tests and ensure our code is working as intended. In addition, dependency injection promotes modularity. It helps to separate concerns and make our code more modular, as each class is responsible for its own functionality and dependencies are passed in from outside. Another benefit is improved maintainability. With dependency injection, our code is easier to maintain and extend over time, as changes to dependencies can make without modifying the dependent class. Furthermore, dependency injection provides flexibility. It allows us to easily swap out dependencies at runtime or configure them differently depending on the environment. Another benefit is improved readability. By making dependency implicit and decoupling classes, our code becomes more readable and easier to understand, making it easier to debug and modify. Dependency injection also promotes collaboration. With it, teams can collaborate more easily, as changes to one part of the code space are less likely to impact other parts of the code. Finally, dependency injection reduces complexity. By breaking down our code into smaller modular components and decoupling dependencies, we can reduce the complexity of our code and make it easier to reason about. Now, let's take a look at the types of dependency injection. There are three main types: constructor injection, setter injection, and interface injection. Constructor injection is the most common type of dependency injection, where dependencies are passed to the class through its constructor. This approach is useful when a class requires its dependencies at the time of creation and when those dependencies are mandatory. Constructor injection also makes it easier to test the class, since dependencies can be marked or substituted with test doubles. Setter injection is an alternative to constructor injection, where dependencies are passed to a class through setter methods. It is useful when a class requires optional dependencies, or when dependencies may change over time. Setter injection can also make the code more readable, since it separates the creation of the object from the setting of its dependencies. Interface injection is a more advanced form of dependency injection, where dependencies are passed to a class through an interface that the class implements. It is useful when a class requires multiple implementation of a dependency, or when a class needs to be extensible and support multiple configuration. In general, constructor injection is the preferred approach of managing dependencies, since it ensures that all dependencies are available at the time of creation and make it easier to test the code. Setter injection and interface injection are useful for more complex scenarios, where dependencies may change over time or multiple configurations are required. As for implementation, there are several ways to implement dependency injection in software development. One approach is manual dependency injection, where dependencies are passed in implicitly through constructor or setters. This can be simple and straightforward for small projects, but can become tedious and error-prone as projects grow in complexity. Another approach is framework-based dependency injection, where a framework manages dependencies, usually through configuration files. Common frameworks include Spring in Java and Angular in TypeScript. This approach can be more complex and powerful, but also more difficult to set up and learn. The service locator pattern is another approach, where a central registry of service provides access to dependencies. Services are registered at runtime and can be looked up by name or type. However, this approach can lead to tight coupling and make it difficult to reason about dependencies. The ambient context pattern involves making dependencies available through a global context object, which can be accessed from anywhere in the code. While this approach can make dependencies more easily accessible, it can also be harder to track and manage. So as we know that there are several ways to implement dependency injection in software development, each with its own benefits and drawbacks. Ultimately, the best approach will depend on the specific needs of a project and the preference of the development team. So what are the best practices to make the most of dependency injection? Let's go over a few important points. First, we should aim to keep our classes small and focused. Each class should have a single responsibility and do one thing well. This helps to reduce complexity and make it easier to manage dependencies. Second, we should use interfaces to define dependencies. By using interfaces, we can decouple our classes from specific implementations and make them more reusable. This makes it easier to swap out different implementations and manage dependencies more efficiently. Finally, if our project has a large number of dependencies, we may want to use a dependency injection framework to simplify the process of managing them. Frameworks like Spring and Daggers provide a centralized way to manage dependencies, making it easier to configure, manage, and test our code. In conclusion, software development is a complex and challenging field, and managing dependencies is a crucial aspect of building maintainable and flexible applications. Dependency injection is an essential technique that allows us to decouple our code from specific implementations and manage dependencies more efficiently. At its core, dependency injection is all about separating the creation of objects from their dependencies. By injecting dependencies into a class rather than having a class create them, we can make our code more modular, reusable, and testable. This approach helps us to reduce coupling between classes, making it easier to modify and maintain our code over time. With this technique, we can easily swap out different implementations of dependencies without changing the code that uses them. This makes our code more adaptable to changes, and it allows us to build more extensible and scalable systems. Thanks for your listening today and hope you now understand further about dependency injection.